I am indeed having a great pleasure to be part of this project, Energy Conservation in Small Tea Sector in South India. The project is funded by UNGP and GEF. $950,000 is the total funding. Tea Board of India, that is the Government of India, has contributed equal contribution for implementing this project. Our operational partner for execution of this project is Tide. It's an NGO based at Bangalore. The main objective of this project is to get the energy conservation measures to the tea industry to conserve energy in terms of fuel wood, power and so on. We have been working in this project for the last 3 years, and this project has been very well received by the industry stakeholders. More than 92 energy audits we have completed, and many factories, more than 30, have actually taken lots of corrective measures based on the energy audits which we have done. This is indeed a very great success for the project, and I am sure this project has really given lots of improvement in terms of energy conservation. Now we have standardized certain practices. These practices, they are all not really exhaustive, but we have standardized these things because they are all really proven and it can reach the people. Accordingly, we wanted to make certain tutorials as a knowledge sharing for the industry. And now we have taken some of the films emphasizing the importance of each and every aspect so that it can reach the people and it can be used in every factory without having any further explanation to be done.
Automatic Power Factor Controller. In tea industry, energy is more precious than time. Maximum utilization of the available resources should be the ultimate aim of any factory. The perfect machine is an ideal term. Every machine, specifically an electrical motor, does not utilize the total energy provided. Some part of the electrical energy is lost in producing magnetizing flux. Thus, the power consumed is not equal to power utilized. Here the term power factor comes in.
To understand what power factor is, it's a little bit technical, and one has to understand the term kW, kVAR and kVA. kW basically is a load that actually is actual power that is being used to run a motor or run any machine for that matter. And kVAR is a reactive power that is creating a surge on the kVA. And kVA basically is a summation of kW and kVAR. Power factor, or in short PF, means the ratio between the power drawn from the grid power line and the power used efficiently by the factory. It is supposed to be a unity or number one, because the energy drawn from the grid should be entirely used by the factory or industry. I said power factor close to 1 or unity is ideal situation, which means power is being very effectively used. If it is poor, it is less than 1 or much less than 0.9 and all. That means which is not efficient. The entire power system requires for a redoing. Thanks to technology, we have a device called a capacitor to control power factor or to improve the power factor. Capacitor is a device that stores charge and releases to compensate the surge in kVAR. The kVA or demand, which is fixed given by the energy supplying authorities, needs to be controlled at a particular level for two reasons. Number one is that it is a fixed one by the energy supplying authority. Every factory needs to pay a demand charge for each kVA sanctioned to the industry. Secondly, for escalating or exceeding this kVA, one has to incur a penalty. I am glad to share the experience of Kaikati factory, which is a cooperative government factory, about the demand control that it has exercised very efficiently through installation of capacitors. By having a fixed 140 kVA demand, we are able to control the cost by the constant cost on kVA demand cost, and also we are able to control escalation above this sanctioned demand by installing the capacitors at 3 different levels, one at the section level and the individual motor level, and then we also have common automatic power factor control. This factory has spent something like 1 lakh rupees approximately on installing capacitors and automatic power factor. Basically, this factory has an individual capacitor of 8 kVA range connected to each motor, which is exceeding 10 kV. Through installation of this capacitor, we have not only controlled the demand, but also we have ensured better power factor, which is closer to number 1, and also we have saved so much on the electricity by controlling the unit cost consumption per kilogram of made tea. Way back in 2007-8, our consumption was in the range of 0.52, and now that it is in the order of 0.45. That means we have ensured a saving of nearly 0.07 unit per kg of made tea. Energy bill saving of nearly 1.8 lakhs a year means annually. It's a very good, impressive saving for this factory, which produces around 9 lakh kilos a year. And already this factory has got back the investment that has been made on this capacitor for controlling the kVA demand and all. And it is for every industry manager, not only one has to be rupee wise, one has to be paisa wise to ensure that one saves energy in long run.
Measuring, improving and maintaining the power factor is the major step towards energy conservation. Automatic power factor controller is the solution. Let's try to achieve maximum power factor for maximum savings and profit. Important recommendations. Conserving energy at every stage must be an aim of any tea factory management. Tide recommends some simple techniques to support the effort of energy conservation. Changing delta connection to star connection. An electrical motor is an essential part of almost every machine in a tea factory. As there are several processes and sections in a factory, motors of different capacities are used. Many of them are below or equal to 5 HP. These motors are used in a great number. There are 2 different types of connection settings on the electrical panel of a motor: delta and a star connection. If we change the connection in the motors from delta to star, we could save the energy and get the good power factor as well. Let's observe the readings of power factor before and after changing a delta connection to a star connection in a motor of capacity 5 HP. Here is a delta connection, and the power factor measured is, and this is the same motor with the star connection. Now power factor we see is, a simple change can give extraordinary results. It needs no extra cost. It is easily applicable in any section of the factory.
As we all know that energy is one of the major inputs that goes into a factory, and therefore it is equally important to manage that resource and input. And therefore, in the case of factory management, we have to see that the energy is conserved or utilized properly. For that, across the departments, we have to have a holistic look, and whilst it is much easier to plan out in the other departments where there are larger motors by converting them into more energy efficient motors in a phased manner, what do we do in a situation where we have what we have in the sifting department? In sifting and grading, we have a plethora of motors which are small size motors, and for which you cannot have a ready replacement, nor can you afford to change so many motors. So what do we do in a situation like that? With this problem, we had to go and find a solution. So that's when we approached Tide, and there we got a unique solution and a very simple solution with their advice to convert these motors or run these motors permanently in the star mode. And once we got that done, we found a solution to the entire problem. So what happened when we converted this into a permanent star mode? We found an immediate improvement in energy by 10%, and more importantly, we found that we could maintain a power factor to the required level, and the most important thing was we did not have to do any extra investment, and our local electrician could put this into a permanent star mode. This is what we in the industry look for, unique ideas like the idea which came from Tide, which needed no extra cost at all, but could give us the required inputs at the required levels.
Section-wise energy meters. To produce made tea from tea leaves is a continuous process. It is divided into sections for convenience. An energy demand of each section is different. Estimating the total energy required is always a difficult task. But measuring the energy consumed is the first step to conserve it. One could get an idea in which section the energy is utilized more than necessary. So Tide recommends section-wise energy meter.
In a factory, there are different sections. Some sections the electrical consumption is less, and some section it is very high. So when you have the section-wise energy meter, you can really study where the electrical consumption is higher, and also you can make the corrections. For example, if you have 6 sections, in some areas, for example in the CTC areas or in the shifting areas, if the energy consumption is very high, we can analyze the scope for further improvements, whether the motor is consuming more energy or what is the problem, we can analyze. So section-wise energy meter is very essential, and it is not very expensive. So section-wise energy meters helps a lot in analyzing the overall performance of the factory. In Highfield Estate factory, we have installed the section-wise energy meters. Earlier we had no section-wise energy meters, and there we used to work based on approximations. After installing this section-wise energy meter, we found that certain areas where we are going wrong, especially in the tea factories, CTC cutting area is the maximum electrical energy consumed. So after installing, we studied the energy consumed in sections, and we went for the energy saving measures. And as a first installment, we started replacing the energy efficient motors in the CTC section. For example, if the energy consumption is 50% in one section and some other section is 10%, you have to focus only in the areas where you are consuming more energy. So if you do some alterations in that section, the benefit will be huge compared to where the section where it is consumption very less. So we could able to achieve the desired results because of the section-wise energy motor readings.
MD controller. The electricity power allotted to any factory is pre-decided as per demand. It is advisable to utilize the energy within this limit to avoid further inconveniences. So here is an important recommendation. MD controller. MD controller is a device to control the electricity consumption as per the maximum demand. Using this device, we can set the maximum limit of the usage in kVA. MD controller continuously records the electricity used after a stipulated time interval. Using these readings, we can manage the power usage in the factory.
Regulation of electricity usage is a very important aspect of a tea industry. Every industry is sanctioned with a particular demand, and this demand has to be maintained very strictly. The allotment of power depends on the amount of units that a tea factory consumes, and the consumption of power depends on the number of motors and the amount of tea that is manufactured. Fixing of the demand levels depend on the sanctioned demand. If a factory is sanctioned 112 kVA, the factory is not expected to cross this demand for a consecutive 2 months. And if this happens, the factory is recommended for a high tension connection. Since the factory has to maintain its sanctioned demand, a MD controller becomes very, very important. MD controller is a device in which the maximum demand can be set. The MD controller works in a particular way in which it triggers an alarm before the maximum demand is reached. And if the maximum demand is reached, it trips the motors to stop the manufacture and bring to the notice of the factory manager. Labor shortage has become a big problem for all the tea factories. Because of this problem, all the factories have gone in for conveyor racing mechanism. Since more conveyor racing has happened, the more motors are being installed in the factory. So this actually brings up your current consumption, and the sanctioned demand is attained very quickly. So if a factory has to maintain the sanctioned demand, the MD controller becomes a very important entity in the factory. MD controller is an important recommendation for all the factories. It has made our life very simple. Thanks to MD controller.
Tea industry is a plantation-based industry where there is significant post-harvest processing. It requires sophisticated machinery. A huge amount of energy is consumed here. It is very necessary to measure and supply appropriate energy to every process to make the production profitable. A very common device used almost in every machine is an electric motor. An electric motor is used to generate torque required. A variety of electric motors of different capacities depending upon loads are used here. Here is a scope to conserve electrical energy. It may happen that a motor of higher capacity is being used at the place where it is not required. To understand the proper load and the capacity of the motor, it is necessary to measure two parameters: percentage loading of motors and the power factor. Simple measurements can lead to considerable saving. The equipments required for measuring are not expensive and easy to use. After knowing the exact energy requirements, there are two ways to reduce energy consumption: downsizing of the motor. If the percentage loading of motors is less than 50%, that is maximum load, they need to be downsized.
There is a lot of scope to downsize the electrical motors in the South Indian tea industries, especially on the rolling section. If you take North India, the power consumption in the rolling section, it is about 100 to 120 horsepower. Whereas coming to South, it is almost we are consuming 150 to 160 horsepower in the rolling section itself. It is mainly because of the raw material as well as the method of process is totally different from North India's. And therefore, even the power reduction in the rolling section, downsizing of motors are very, very important in South Indian tea industries. The reason is we have gone for more than the capacity in the CTC rollers. For example, if you take rotor van and CTC, you start from the 40 horsepower, 30, 30, 25 and 25 like that. Whereas North, it will be only maximum of 25 horsepower. So we have gone for always the higher capacity motors in the South Indian tea industries, and definitely there is a scope, a minimum you can reduce 5 horsepower from the existing level in the rolling section itself.
Using an energy efficient motor. An energy efficient motor, as the name suggests, consumes less energy than a conventional motor. It gives 10% of more power savings on operating kilowatts.
In the cost of manufacture of tea, the major portion is being taken by electrical energy, and after the recommendations given by Tide, factories have now gone in for energy efficient motors. We also in our factory have gone in for energy efficient motors. And energy efficient motors, though they may be slightly costly, they definitely give a 10 to 12% savings in energy, and in the long run this definitely helps the factory. Energy efficient motors, they are of very good make. The winding in the motors is very good, and they use the latest technology, so they serve very well. Energy efficient motors, they are more durable, there is very less breakdown, and it also avoids downtime. The maintenance is very less. The myth that the energy efficient motors are, the maintenance is more, is definitely very false. We have been using energy efficient motors in our factory, and we are very happy with it, and we are very happy that Tide has given these recommendations for us, and we have saved a lot of energy and money.
Tide technical team has prepared performance study on energy efficient motors in several factories in South India. Here is the result in power savings after installing an energy efficient motor in various processes. Akshay Tea Factory, CTC, saving of 7.7%. Balanur Plantation Tea Factory, pulverizer motor, saving of 12%. Highfield Tea Factory, total power, savings of 12.8%. Shri Bathma Tea Factory, withering section, saving of 10%, and in CTC section, saving of 12.5%. Sholaya Tea Factory, rotor vane, savings of 10%. Saving energy is saving money. Conservation of energy is as important as utilization of energy. Let's look at our industry with a futuristic approach where the energy is the most important thing. A tea factory is a great example of engineering excellence. Here, many complex processes are carried out hand in hand, and electrical energy is consumed enormously. To save energy is always a challenge in front of any tea factory. By understanding simple physics, we can achieve it to a great extent and make the processes more profitable. Observing machines carefully, we can find many areas of energy losses. A belt is a very commonly used part in almost every machine. Belt is a device connecting an electric motor to pulley to transfer rotating motion. In other words, belt transfers mechanical energy from one place to another. In many factories, generally V-type of belts are used. V-belt has a pattern of grooves on it. Studying the structure and function of V-belt keenly, in the light of energy conservation, we found some disadvantages. A flat belt could replace a V-belt to give more energy efficiency. Let's compare a flat belt to a V-belt. Here are some important reasons of recommending a flat belt. There is more friction in the case of V-belt due to engagement between the lateral wedge surfaces of the belt profile, whereas there is less friction in the case of flat belt due to engagement on the outer pulley diameter. In the case of V-belt, the bending cross-section is big, so mass is large. It consumes more energy. Whereas, in the case of flat belt, the bending cross-section is small, so mass is also less. It consumes less energy. There are different effective diameters in V-belts, so it gives varying speeds of individual belts. There is precisely defined effective diameter across the flat belt width results in exact speed. Flat belt saves 5% of operating energy than of V-belt drives. An improperly tensioned or wobbling V-belt leads to substantial losses. The maximum efficiency attained by the flat belt is 98%.
I, for instance, have deployed major drives. They're all flat belt drives, which includes my rotor vane, dryer, and 5 cuts of CTCs. Traditionally, all of us have been using the V-belt pulleys till now. The main advantage when you use a flat belt pulley is that it's got a better grip. The flat belt and the pulley, they are both flat, so there's a larger surface area in contact of the belt with the pulley. So there is a more of the inertia is created, and it results in a better energy saving.
These are the salient features of a flat belt: efficiency and energy savings. Small amount of deformation results in higher efficiency. Operation life. Equal friction over the pulley gives less wear and tear. Minimal maintenance. Maintenance cost of a flat belt drive is negligible. Smooth running. Uniform distribution of tension over the entire belt width avoids vibrations, fluttering and noisy running. Chemical and electrical properties. Flat belts are manufactured from synthetic material, polyamide with elastomer. They are normally resistant to oil, water, and most commonly used chemicals in industries. The belts are also anti-static and electrically resistant. Easy installation. Flat belts can be installed very easily and securely.
From V-belt to flat belt, we start changing the belts recently, and we found it is very easy to change to flat belts, and most of our rotor vane, rollers and tea dryers we changed to flat belt, and we found that very energy efficient these belts and much durable also. And if all the tea industries in tea factories in South India goes for flat belt, there will be a tremendous energy saving.
Cost effectiveness. In assessing which drive system is the more economic in the long term, the following aspects have to be taken into account. For example, in a case of a belt drive, if a motor rated output is 75 kilowatt, operating hours are 6,000 per year and life expectancy is 10 years, then initial outlays, market prices of pulleys is 80% and that of belts is 20% of system price. Maintenance cost of a V-belt drive is considerable. Maintenance cost of a flat belt drive is negligible. Long-term costs, cost of spare parts distributed over 10 years. And finally, energy costs. Let's see this graph carefully. TIDE technical team performed a study on power saving by changing V-belt to a flat belt in the following factories, and the results were amazing. At Highfield Tea Factory, power savings of 7.7% in hot air fan. At Kaikati Tea Factory, power savings of 8.1% in CTC section. At Typhoid Tea Factory, power savings of 6.5% in pulverizer section. Small things can cause big changes. Come on, let's save energy. Let's be prepared for a prosperous future.
The Tea Board of India, South India office has been working on the energy conservation project for the last 3 years, and we have been promoting the energy conservation practices all across the tea industry, and we have been quite successful in getting our targets achieved. We have taken up the new initiative of promoting the renewable energy resources. Now, on that first step, we have taken the LED lighting to be fitted all over the tea factory to save the power crisis. Initially, Tea Board office itself wants to work as a pioneering office, and we have fitted LED lighting all over the office. As soon as we fitted the LED lighting, I had checked up with our own officers and staff the feel of this lighting in comparison with the conventional lighting. They have all appreciated this lighting, and if possible in future we are also thinking in collaboration with MNRE and of course our working partner TIDE and UNDP and GEF, we would like to take solar and other renewables in association with other gasifiers and various technologies which are used for tea production. It would definitely give the desired benefit not only for the industries but also for the country.
Kaikati Inco Tea Factory is a cooperative tea factory. We are very particular about controlling the cost, wherein the Tide project suggestions come into play, which are very vital. One important suggestion given by the Tide was that we should conserve energy in the lighting sector, wherein we incur something like 2,200 watts every year. So invariably, we have to check in the wattage saved, as well as we have to check in the lifespan, that is lifespan of the light. Quite often what happens, we had a requirement of changing the bulb and all. So invariably we have to think of alternative to the fluorescent lamp. Secondly, the fluorescent lamp had a distinct disadvantage in the factory atmosphere, particularly in the food industry like tea industry, where the mercury poisoning counts so much. Suppose as you know, over the CTC we have installed a set of tube lights. If it breaks and falls on the CTC, what will happen? The entire goods will have to be discarded. That's a big thing about having tube lights in the factory. Every industry, and as a corporate or cooperative, responsible factory has to be very careful about this mercury poisoning. So we just thought we should look for some alternative. The handily came this aspect called LED lighting. LED lighting, the advantages are known to everybody, and in the factory atmosphere it is really very relevant. Kaikati Inco Tea Factory has been assessed for changing over to adoption to total LED. The whole office as well as entire factory, including that loft as well as CTC area and sitting area. And it's promisingly they say that we can very well go in for. And as a first effort, we have changed over all our office and cabin of special officer as well as computer room into LED lighting. And we have done some LED lighting outside also in the open premises, and it has been quite promising. As of now, all our staff, visitors are quite comfortable with that. Curiously, they just asking, what's the kind of lighting that you have. Invariably, it is quite comfortable for them also.
Now a 40 watts tube light has 40 lumens per watt, which goes up to 1600 lumens per watt. Now 1600 lumens is spread over a 360-degree area, which means this 1600 lumens, effectively you get only about 20% of the entire 1600 lumens, because that is what you're going to use to light up the area that is specific. Now instead of wasting this 80% of light, if I could channelize, if I could focus the entire 1600 lumens to a work area, let's say 2 by 2 or a 3 by 3 disk. And this is exactly what LED does. By virtue of its orientation, by virtue of the dispersion angle that can be used in LEDs. LED is basically a light emitting diode. In any other light form of light, as in the case of a tube light, you need to have gases running inside which gets heated up and then the light is emitted. But in the case of the LED, it's just a simple electronics, which means as electricity is passed through the diode, it produces energy and it starts glowing. I could replace a 40 watts tube light with a 9 watt LED, or maximum I would go to a 12 watt LED. So we are getting about 1200 lumens from a 12 watt LED. Now this 1200 lumens, let's say I want to light up a 10 by 10 room, which you're going to light up with a 40 watts tube light. Now I'm going to put it on the ceiling, this 12 watts LED light, and I'm going to give it a 93 degree or a 120 degree angle, and so that the entire 1200 lumens would be used in an area which should be like this. Sort of, if I want to make it slightly more focused, I could use something like this. Now I want to make it slightly more, expand the area where the light could be lower, but I want a wider coverage, I would put a 120 degree angle. In any other lighting, the moment you switch on the bulb, it starts fading. It fades from the first hour onwards. But in the case of an LED, the fading starts after the 35,000 hours. So there would be very gradual fading from the 35,000 hours till the 35,000 hours, which we are talking about 10 years, would be, the light output would be even. One of the main areas that we focus on is the withering troughs and the CTC areas. Initially, we did an audit at the Highfield factory, and we found that in the withering section, the withering trough section, there were about 3 to 4 tube lights, which were being used for a 6 feet wide and a 60 feet long trough. What we wanted to was reduce the consumption and also to give even lighting, which the tube lights were not giving. Now we put a 5 watt light on every beam, which means we put 30 watts of light, 6 lights. We had totally 6 beams in between, and we put 30 watts of light as against 120 watts, or that is 3 tube lights which were in the same area. And we found that we were getting about 30 lux. Lux is a measurement of light at the level of the task area. Then we shifted our focus to the CTC area. Now one of the main things which we found out inside the tea industry was the gathering of fine tea dust wherever possible. It was just all permeating. And most of the lights had either faded or had become dark or had a fine brown film of dust on them, which means their output was further being reduced. Now LED does not settle on the diode. We matched everything together, the fitting, the light placement, the requirement, the actual requirement, because you got to understand that it was green. That in a dark area, people were actually dropping in dark tea leaves, and they had to see whether it was wet or dry. LED also has another thing called color entering index. Color entering index is the way eye sees color, which means the green which they could see, wet green or the dry green leaf, looked as it should look. So that was another angle which was appreciated very much by the Highfield users. Every other area of the factory can also be lit with LEDs with a lot of energy efficiency, with a lot of energy saving that can be done out of it, apart from the environmental aspect.
LED lighting, though it is a little costlier on the capital part of it, but it is going to be really helpful over a period of time. Within 2 years, we can recover the entire cost. The operational cost is very less, and it also has the flexibility to adopt whatever lighting we need according to the situation, so that we don't need to waste energy at all. And I'm sure this is going to be the future, and it is going to really be very helpful in conserving our energy in a big way.
Tea industry. It is one of the leading agricultural industries in India. India is one of the largest tea producing countries in the world. For years, the technology of tea production has been well established. The production of tea consumes enormous thermal and electrical energies at every stage. Saving energy can make tea making more profitable. Drying process. This is the most crucial process in the tea production. Tea dhool is dried in a dryer at fixed temperature. The ideal temperature in the case of orthodox tea is 110 degrees Celsius and 140 degrees Celsius in the case of CTC tea. It may vary according to the dryer inlet moisture content in the wet dhool. Maintaining precise temperature in the dryer is the key to achieve optimum quality of made tea. And the good quality gives the good market price. We will now see how a dryer works. Here is a conventional process of drying. This is a furnace. Fresh air from atmosphere is induced from this air intake area to accelerate the burning process. After fuel combustion, flue gases enter into the pipes surrounding the burning chamber. Flue gases are sucked out with the help of an ID fan and passed to chimney for outlet. Here are another fresh air intakes at the top of this furnace. Fresh ambient air is sucked in from here. It enters in the closed area around the hot flue gas pipes. This fresh air gets heated due to hot pipes without getting mixed with the flue gases. And then this clean hot air is blown on tea dhool in the dryer. Tea industries are practicing the same drying process over the years. Let's see it in the light of some important factors like fuel consumption. The required temperature is maintained by regulating the fuel feeding, but the fuel feeding is manual and difficult to control. Pollution. As more fuel is burnt, more pollution is created. Production cost. Production cost increases as we use more fuel than required. Quality. If the temperature is not maintained accurately, it affects the quality of made tea. And the most important is the price. If the quality of made tea is not maintained up to the mark, it can't get good market price. Thanks to new improved technology, drying process could be more energy efficient now. The goal is to maintain the optimum temperature using minimum fuel. The heat generation is directly proportional to the amount of induced air for burning. More the air induced for combustion, more the heat generated. So, varying the speed of an ID fan, amount of air intake can be controlled and so the temperature. Here is an ID controller, that is, induced draft controller. It controls the speed of an ID fan automatically to maintain optimum temperature in the dryer. An ID controller monitors minute temperature changes in the dryer section. We can set the value of required temperature for drying. In this case, we are setting it to 90 degrees Celsius for orthodox tea as per the moisture content in the wet dhool. An ID fan motor is capable of rotating with two set frequencies, 50 Hz and 30 Hz. That means it can rotate with 100% and 60% of the rated speed. If the temperature increases than the required value, an ID controller automatically sets the fan speed to the lower RPM, that is to 30 Hz. Amount of air intake is reduced, so the burning process slows down. Heat generation is controlled and optimum temperature is maintained. In the case of decreasing the temperature in drying section, same process could get reversed. Optimum temperature is maintained. We saw the usage of an ID controller to govern the temperature of the dryer. It saves the fuel, improves quality of the made tea, and increases profit. Many manufacturers have already installed an ID controller in their factories. Let's listen to the experiences of the end users.
I am a furnace operator. After installing an ID controller, working on furnace has become much easier. Drying process requires less inspection. We can control the quality of made tea using minimum fuel. Now hygienic conditions are better than previous, thanks to ID controller.
After installing the ID control in our dryer, we feel the quality is little improved, and we are feeling that the consistency from the beginning of the manufacture up to the end seems to be same, and it is not necessary to monitor the temperature often as previous. And also we feel the ash contents in the tubes seems to be very less when compared to the past.
We produce close to 8 lakh kg of black tea annually. We use firewood as fuel to dry our teas. So nowadays getting firewood is very difficult. Also the cost of firewood is increasing day by day. And also we are using unskilled laborers to use the firewood. So normally we use 120 degree to dry our teas. But when there is no control over firewood feeding in the furnace, and ultimately there is a wastage of fuel. So this is the one area we are very worried about, how to reduce this quantity of firewood. So we thought of going for this ID controller. We installed the ID controller in our factory, and we are monitoring its performance, and we have achieved close to 10 to 12% of net saving in firewood consumption. Apart from this fuel saving, the quality of the product is also improved because we are maintaining the steady temperature in the dryer. So we are very happy with the ID controller performance, and there is no trouble so far. It is easy to monitor and also handle.
Better working environment, less pollution, quality and profit could be achieved using simple techniques like an ID controller. Modern approach would take tea industry on prosperous path. In tea making process, firewood is used enormously to generate heat. Maintaining exact temperature in a dryer is a crucial task on which the quality of the made tea is dependent. Constant and regular supply of firewood with equal quality helps to maintain it. But it is based on the assumption that each lot of the firewood will produce same amount of heat, which is not practically true. Here, moisture content in firewood plays important role. More the moisture, less the heat generated. So there is poor heat transfer from flue gases to the fresh air to be used in dryer. Tide conducted a performance study on the heater and dryer, and the overall efficiency was estimated to be around 25% only. the efficiency of the heater alone was 45 to 48%. Here, moisture content in firewood plays important role. Tide recommends to lower the moisture content in firewood to achieve better results. The firewood normally has higher moisture content when it comes to factory, and it gives ineffective combustion. If firewood is stored in an open area, it picks up more moisture from atmosphere. Rain and mist are the uncontrollable factors. Therefore, it is important to keep firewood in a shed to keep moisture level low. It improves fuel consumption by 2 to 4%. It is not very costly, so the payback period is also very less. In southern India, over the 20 factories have already built the wood shed and experiencing better results. Now, we will see the another effective way of reducing the moisture content in firewood. Wood splitter. The moisture content in a big wood log is always more than the small pieces, as the moisture is trapped in the structure of wood. If the wood is split into smaller pieces, more the area of it will be exposed and the moisture will be evaporated. Wood releases the moisture along with the time. It results in better combustion, higher heat transfer and lesser fuel consumption. Tide technical team conducted a study and measured the moisture content in wood pieces. When wood was cut into 4 pieces and kept for drying, the moisture reduction was much higher. This is how it works. Hence, the suggestion made here is to install a wood splitter in the factory. This is a very cost-effective device which is also easy to use. It gives extra savings in fuel by 3 to 5%. Up till now, wood splitter is installed in roughly 40 factories. It skips the tiresome job of cutting the wood logs. Hence, manpower and man-hours are saved.
The availability of firewood is getting scarce every day, and we are not able to get the firewood as per our requirements. We get firewood in all sizes and shapes, and it makes us difficult for us to use in terms of man days and usage. The firewood received at the factory is freshly cut and with lot of moisture. This results in less efficiency and leads to usage of more firewood for drying kilo of methi. With every lot of firewood received at the factory being different, the moisture content also varies. Now with a firewood splitter placed, it splits the wood and it makes it more or less equal in course of time. This results in much more consistent thermal efficiency in heating the hot water. The best part of firewood splitter is the firewood is split into smaller pieces, so handling and also feeding into the dryer becomes much easier, which increases the efficiency of the manpower there.
Before putting this wood splitter, we had huge manpower onto for cutting of the firewood. Apart from that, we also couldn't remove the moisture from the firewood. After we install this machine, we are able to right now bring down our manpower, plus we are able to remove the entire moisture from the firewood. If a lot of moisture is there, our dryers, the fire banks, all of them start dripping with water and they wear out also very quickly. I would say that in future getting manpower would be very, very difficult. So every factory owner should think that it is not a capital expenditure, but to save on manpower, they have to install this. If you really calculate it, the payback will be less than a year for the money we've spent on the firewood splitter.
Simple thoughts give better results if carried out effectively. Drying process is an important process in tea making. The quality of the made tea is dependent on this process. It consumes enormous electrical as well as heat energy to create certain amount of temperature in a dryer. Tide recommends hot water generator to make this process more energy efficient and eco-friendly.
In September 2009, when I met a supplier of hot water generator, they explained to me that you could have a saving of 20 to 30% of firewood. The higher capital cost will be offset by the savings on firewood. Since a hot water generator has a closed circuit of the hot water which is heated to about 160-170 degrees and fed into the radiator, which exits the radiator at around about 140, needs to be only heated up from 140 to 160 again. And also the ambient air which is being fed into the furnace or heater is also preheated using a preheater, and the temperatures from about 30 degrees is heated up to about 70 degrees centigrade. And also superior carbon steel materials are used against cast iron and the air heater, and this also has a better heat transfer, and this is the reason why it's more efficient than the air heater, which has a efficiency of only about 55 to 60%. And our company took a decision in June 2010 to go in for a hot water generator.
We selected hot water generator system because we found there is a scope of reducing the energy cost by 20%, and it is much more safer than the earlier system what we used, and also the heat efficiency which has been much higher in this hot water generator when compared to hot air generators. Against the projected cost of 20% saving, now we have been using this hot water system for the past 8 months, and our figures shows there is 15% saving so far. However, we feel that the 20% is very much possible in the months to come. The unique feature of our hot water generator is that we have 2 dryers with 2 different temperature regimes, and now with one single source of heat we are able to run this successfully and with precision. Our experiences with this hot water generator system is that because of the low maintenance, the downtime is very less. The advantage is that with the precise temperatures being maintained which is required for the best drying, the quality is always at the best. This hot water generator system is fit for continuous working, which is ideal for high cropping months. Now let's go and see how the system works.
This is a hot water generator. Hot water is recycled in the boiler again to save the waste heat. The preheated water at the temperature around 140 degrees Celsius is supplied to the boiler through this circulation pump. Heat is generated by burning fuel wood in the furnace. The hot water is again heated to reach the temperature 160 degrees Celsius. This hot water gets out through this pipe at the top of the furnace. This hot water is supplied to the radiator through these small pipes. This is a radiator. The fresh air from atmosphere is sucked inside by the fan. This air gets heated in the radiator by means of the hot water pipes and thrown on the tea dhool in the dryer. The drying process of tea is carried out by this hot air. Now, here is the recycling of the heat of the flue gases coming out of the furnace. Flue gases are took out through these pipes for outlet. The temperature of the flue gas is 198 degrees Celsius. If the temperature of the flue gases exceed 280 degrees Celsius, siren will blow as a safety measure. This is the intake pipe for fresh air to burn in the furnace. The fresh air is taken in and heated by means of the hot flue gas pipes. The preheated fresh air is then supplied to furnace for combustion. This is the flue gas temperature after preheating of fresh air. And the flue gases are sucked out to pass to chimney. Factories are adopting this method due to its fuel efficiency and eco-friendliness.
From the savings we have worked, we have got a capacity of about 10 lakh kgs of made tea per year, and we have worked out our savings, and we have a savings of approximately 20 lakhs per year.
To sum up, I would like to say that we are very happy with the hot water generator system.
New energy efficient ways will lead the tea industry to prosperity. A tea making process requires huge machinery. Maintaining this machinery is a difficult task. Inspecting many small things regularly keeps the machines in good condition and reduces breakdowns. Overlooking these things could prove to be expensive over the long period in terms of the life of machines or energy consumption. Constant monitoring the processes is beneficial economically as well as environmental point of view. Practicing energy conservation measures must be adopted as an industrial lifestyle. It also helps to create a safe and accident-free industrial environment. This attentive approach is called housekeeping.
When we talk about housekeeping, we are talking about electrical and mechanical housekeeping. The importance is all the more magnified in an industry like tea estate, where you don't have an access to machineries or repairmen or people who can do the specific technical jobs at a short notice. So we have to be preventive in our breakdowns and be as much less on breakdown time, so that the process goes on in time and manufacture is not delayed, because tea leaf is a perishable commodity. The more you are having a delay due to a breakdown, and more so it's magnified during a cropping season, when if there is a breakdown, you will have a multiplying effect in the sense that you will have a pile up of leaf and you will not be able to finish your manufacture. Because of this, housekeeping is something which is an absolute essential part of tea industry and the factory. Basically, looking at the machinery upkeep and housekeeping, there has to be an awareness by the people who do this job. That is our mechanical foreman, the mechanical section, the electrical foreman, the electrical section, the wiremen and the blacksmiths. This is the team which works in the factory, which looks after all the mechanical and electrical maintenance and the housekeeping in general. And whenever we have a breakdown in a shift, if it is at night, these people are informed in writing next day in morning to do the repairs, so that the next day morning when the manufacture has been done, there is no further breakdown or there is no further hiccups in our manufacture.
Now when we are doing this, then awareness that we have to do the maintenance in time, and we have to make sure that all the necessary spares are there. General checking of the connections have been done, so that as mentioned earlier, we don't really get into a situation wherein we have a huge breakdown time. When we are talking about scheduling of maintenance or housekeeping, as we call it, it is basically we have to do annual maintenance for all our machineries which have been running for a year. In a factory which is producing almost 8 to 9 lakh kilos of tea, like in Dunsandel, we have to do our maintenance during the lean months. We have to schedule to stop some machinery when the crops are low, change the parts like which are bearings, and change the motor bearings, or we have to do the wiring or rewiring of motors if required, change the fuses, fuse carriers if required, so that when the crop comes again and the cropping season starts, we don't get into a situation where we have a breakdown due to these aspects. Hence, that is one thing which we have to look into at all the point of time. And then we have to schedule it in such a way that our breakdown maintenance and annual maintenance don't come together. And annual maintenance, when it is done keeping in mind that the other processes are going on without stopping the factory. So you are running the factory, meanwhile you are maintaining the machineries which have to be maintained. So you do stop one machine at a time and do it in a schedule. So for that you have to plan to have your spares ready, your manpower ready, and the people have to be trained to do that. That apart, mechanical maintenance and electrical maintenance of regular nature of changing of fuse carriers or changing connections, removing of dust, use of safety equipments, these are the things which are ongoing and for which you have to have training and a team for that. Like we have a housekeeping training team, or we have a safety committee over here in our factory which looks into this aspect, and we have regular updates on the different aspects of the section-wise maintenance. That could be in rolling section, fermenting section, withering section, or in sifting section. In the end, I would like to conclude by one saying, that is, a stitch in time saves 9. That is, if you save 1 rupee in housekeeping, you will save 9 rupees in your manufacturing cost. So housekeeping is something which we should not overlook and keep it in our mind whenever we are running our factory.
We will now see some of the important points in several sections of a factory. Let's begin with the most important place, an electric transformer. That is the powerhouse of the factory. There should be a lightning arrestor fitted at the top of the transformer to prevent from lightning. The transformer should be installed properly on a neatly built strong structure. And the transformer must be earthed properly. Earthing pits should be clean. Transformer yard must be clean and filled with blue metal or gravel. The yard must be protected by a sturdy metal fence. The fencing should be earthed with copper wires. Electrical wiring outside the factory must not be kept hanging like this. Wires should be joined properly and safely to prevent any mishaps. Now let's go inside the factory. These are the MV panels. Make sure that the bolts of the panels are well fitted and not rusty. In front of the panels, there must be a rubber pad of thickness 10 mm on the floor for an operator to stand on. It will work as a good insulator. There must be an emergency lamp ready near any panel. The rear side of the panels should be well lit and open. The panels must have a double earthing. Here we see is a single earthing. This is a generator control panel. The cables inside must be placed very neatly. They must not touch each other. In that case, they should be separated by an insulator. It should be provided with a neutral link. The copper wires of earthing must not touch anywhere else. The cable should be passed through a trench. This trench should not be left open like this. The industrial quality switches must be used in a factory and not the domestic ones. This is not a good wiring of a motor we see here. Main control cable is connected by an ordinary wire. Use of armored cable is strongly recommended. The motor should be provided with double earthing. Here, the incomer to CFM main control panel is connected by an ordinary wire only. It should be replaced by an armored cable. The panel must be double earthed. The fuses should not be left open and must be installed with proper fuse wires with required thickness. In every section, motor cables must be glanded properly. All the motors must be provided with double earthing. The motor cable here is joined directly. Use kit joint in this case. All the control panel cables need proper glanding. In withering section, glands must be provided at the cable entry point and the control panel must have a double earthing. The cables of trough motors should not be strewn over the floor like this. These should be laid properly. In every section, there must be a first aid box. And electric insulating gloves must be kept in all high voltage areas. The operator must not work without these gloves. All these measures will take care of energy losses and will create a safe working environment.
The TIDE has conducted an energy audit very successfully, and we have been implemented all the TIDE recommendation, and we found about 10 to 15% of saving in the energy. Housekeeping, we do it in Chamraj on a regular basis. We train the grassroots workers in regular training, especially with the outside and internal training also. In housekeeping, we have not spent much money, and we are able to maintain all our machineries in very good order.
Housekeeping is very important for both safety and maintenance. It should be given priority and implemented with strict discipline. Housekeeping can drastically reduce the number of accidents in the factory, creating a safe working environment for the employees. It can also reduce the chances of fire accidents happening in the factory. So it's very important to follow discipline of housekeeping. Machinery maintenance is also very important and should be prioritized. Tea factories are prone to breakdowns, and this can be reduced drastically by good periodical maintenance and housekeeping.
I am glad, the technical team of TIDE, it was all along with KICAT & Co for quite some time, and not only in controlling the cost, energy cost, but also in doing some studies on housekeeping. Recently, they were good enough to send our factory a good report on housekeeping, and they have pointed out some loose ends which are good enough for us to have very good control on, internal control, and specific directions have been issued to the concerned section electricians and all, and this is good enough for us. Thank you.
We want this project to go further on with the support of the stakeholders, because it cannot be a closing point at this moment, because it has to go further, a long way to go on energy conservation, but also we want to add up renewable energy opportunities within the tea sector, and I'm sure we will have a full cooperation from the tea sector people, and we are also linking it up with the other ministries, MNRE, and the state agencies who are giving the subsidies for the various people in this particular endeavor. So we would able to take these subsidies and financials to the industry so that we could able to really take this energy conservation process further. Therefore, I feel that all the stakeholders should take active interest and get their energy audits done, and also they should give us the feedback on the best practices or innovations which are really done within their own level, which can be added up to us, and that good practices can be spread further to the industry, which will be of really a great help for all of us.